Okay, so first of all, a very happy new year to everyone. And it's great to be here as part of the Electronics Industry Day. So my co-presenter Arun and I, we have been with Silicon Labs for a few years now. So we are extremely grateful to Silicon Labs, SSIA, and IT for allowing us to address this very diverse audience. So in this presentation, we'll go through in brief what kind of education you will need to become an engineer in the industry, and also share with you in brief our stories. So before we get into it, just a quick intro into what is Silicon Labs. So we are a fabless semicon company, and we get some third parties to manufacture the chip for us. So like what Eugene mentioned, like Google's and Apple's, they get their chips manufactured by TSMC. So we also depend on third parties to help manufacture the chip for us. But unlike them, we focus on the IoT industry, and we make very low power chips with wireless capabilities. Okay, getting right into the matter. So what is the required education that you will need if you want to become an engineer in the semiconductor industry? So first and foremost, the basic thing is to get your general education, which will be the PSLEs, followed by your A-levels or the IT or poly diplomas. After that, you go into your tertiary education, which will be the bachelor's degrees from any local university or any overseas university, which is also focused on engineering. So typically, the bachelor's degree will be 4 years, with the last 2 years focused mainly on some specialization that you will want to do in terms of engineering. So the industry also is a very evolving, dynamic industry. So that means you need to continue your education even after you graduate. So a lot of times engineers, they do their master and PhD after they start working, or sometimes they right away after graduation, they go into their masters and PhD to do their post-graduation. So I've broadly classified some of the branches that you will encounter in the semiconductor industry to the research and development, product management, operations, manufacturing. And just listed are some of the engineering streams which will be like the least path of resistance to get into any of these branches. And yeah, so you can just follow these and take up anything based on your passion. Maybe you want to do R&D, then you can do your engineering in electronics and electrical and electronics. Or if you want to do project management, maybe you can do industrial and systems engineering. So for the next part, I'll hand over the mic to Arun.
Yeah. Thank you, Hari, and thank you, Paige, for the kind introduction. So here I'm going to talk about how your engineering journey is going to look like. So the first left half portion is basically your journey as a student, and the right side is basically your journey as an engineer. So it starts off with GCE O-level. So at this portion of time, you would have two options to choose, either to go to A-level or JC, or you might also go for occasional diploma, which is basically, in ITE or poly. So once you had completed, then it's important that you go and do an engineering degree, which can be either in science or engineering, which is basically a bachelor's. So at this period of time, either while doing a diploma or poly, or during your engineering time, it's highly recommended you do an internship, because while doing internship, it's the actual time where you could actually sense, the industry experience and life. So based on that, you might also decide how your passion and future is going to be. So at the end of your engineering or university degree, you would start tasting, work life, and typically you start as an NCG, whom they call it as a new college graduate. So once you have completed the new college graduate, and once you go above the ladder, you start moving into senior roles. At this portion of time, with semiconductor industry background, you would typically be on sales side, or you can be on the R&D side, or you can be on the manufacturing side. So once you cross above the ladder, it's up to you to decide whether do you wanted to go towards leadership side, or do you wanted to go towards technical side. And this step basically explains you the flow, how you would envision to see. And in the next slide, these are the people, how it goes into a product life cycle. So typically, before a product gets introduced, our marketing team generally goes and collects feedback from our customers, generally to get what is the end application that they wanted to do. And then this gets passed on to our design team, where they would do the research and development. So in this case, they would come and design a chip. So once the chip is designed, then it goes to the new product introduction team, basically the engineering team, to go and introduce the part. And once the first set of part has been produced, we typically launch the part, and that's where our sales team takes this part. We ship it to our end customers to sell it. And once we have received orders from our customers, then that's where we typically manufacture our parts, and we then ship it to our end customers tied to specific application. And below are some list of our employees who work on different stages of this life cycle. And I would really like to point to Jennifer Tiong, who is also our chairman of SSIA, and she's also our vice president of manufacturing operations, and she has done her master's in engineering. In the next slide, I will pass on to Hari, and where we would be talking about on our day-to-day life as an engineer.
Thank you, Arun. So in this section, we'll both share how our day-to-day activities look like. And before we get into it, just a quick introduction into IC development cycle, just from our perspective. So I stand as a representative for the design and fab out section, and Arun will be part of manufacturing. So in design, we design and implement the chip and send the design for manufacturing to a third party like TSMC or Global Foundries. So this cycle typically takes a year or 2 months until it comes back to us for our testing purpose. It goes through many different cycles before it reaches Arun in the manufacturing side, and from there it takes about another year to send the parts out and it reaches the customers. So you can say it's about 2-year cycle when you start designing a product until it reaches the end customer. So this is how both of our journeys look like until now. So we finished our secondary school around 2003, 2004 time, and completed our JCs in the science stream, taking maths and science. So I did my bachelor's in electronics and instrumentation, followed by my first job, which was also involved with IC design. And after that, I did my master's from NTU, specializing in IC design. And now I'm part of Silicon Labs, working with the digital design team.
My experience is very similar to Hari, as you could see here. We both did our bachelor's in electrical, but the important thing which separated our path was Hari's first job and my internship, where Hari's first job was more towards design and mine was more towards software and coding. And that is where our path got split, and we did our specialization, basically a master's in our specialized interest, and we are now working. Hari is working on the design engineering side, and I'm working more on the data analyst side for almost few years now in Silicon Labs.
Okay, so this is how the day as a digital design engineer will look like. So just to say a disclaimer out there, this is not what we do every day. It's just that our function will involve one of these sections on a day-to-day basis. So what does a digital design engineer do? So we do design, implementation, and the verification of the digital circuits, which are making up all the ICs that are going into the customers. So it starts with a high-level process where all the different teams come together and discuss on different specifications. Let's say you want to do an IoT chip, and then what are the requirements? Maybe it needs a Bluetooth, a Wi-Fi, so and so. And once that everyone's agreed on what kind of spec are needed, then it goes into an architecture phase where we decide how do you put all these spec together in terms of components needed and what kind of frequencies that you are needed and all these different architectures for CPU and everything. So once that architecture is done, we go into the design phase where we actually sit and code the designs into something like a hardware description language or even a C code or Python code. So once the design is done, it goes into an implementation phase where we convert the code that a designer has written into actual physical entities. And finally, we send it out to a fabrication house like a TSMC, And after 2 months, it comes back to us, to our labs, where we test it, and it goes through the whole manufacturing cycle before it reaches the end customer. So I've broadly defined the skills needed for a digital design engineer based on 3 different streams. You can either go into design, or verification, or implementation. So design will mainly focus on writing HDL codes and coming up with architectures that are needed for different chips, maybe Bluetooth or Wi-Fi. The verification engineer's task is mainly to make sure the design that the designer has coded, it works properly. And it works properly in terms of the spec, that it meets all the specifications that are needed. And implementation engineer is mainly, he takes the designer's code and converts it into a physical layout that can finally be sent out to a manufacturing house. So if you see all 3 branches, they need very similar basic and advanced skills. So like basic, you need some STEM knowledge, like algebras, number systems. And on advanced level, you need understanding of logic systems, logic circuits, programming, and so on. So some basic thing you will learn during your secondary, and advanced thing you will probably learn during your tertiary education.
Thank you, Hari. So once typically the fab out is get completed, that's when we do the new product introduction, and we typically start manufacturing. And the total cycle, lead time which needs to manufacture millions of chip typically takes up to 1 year. So the next slide talks about simple semiconductor manufacturing process. The left portion of site, we basically have 3 steps. The first step is what we called it as front end, where we actually fabricate the wafer. And once the wafers are fabricated, we typically cut those wafers and get those small chips which can be shipped to our customers, and our customers generally use it for their end application. The top right portion of the image talks about various steps that is involved in this semiconductor process for both front end and back end. And the bottom right image talks how the wafers gets converted into the end applications that we are actually shipping to our end customers. As you could see that there are lots and lots of process there, and typically manufacturing is 24/7, so there's going to be lots and lots of data. So that is where I come in for my team to to consolidate the data and generate reporting, so that my manufacturing leaders and executives uses that to speak to the customers or to speak to our suppliers to make some decision. So basically, the study of this is called as data science. Data science is nothing but study of data, where we collect the data, transform the data, and create insights to make meaningful information. The left portion of this image is nothing but a simple chart. The chart might look simple, but to get this data is very challenging. First, we need to get the data, and the last portion of it is what we predict from this data. And the next slide talks about a day as a life as a data engineer. It is very similar to what Hari has mentioned. On one particular day, we will be just focused on one specific box that we have highlighted here. So our intention is to create meaningful insights. First, we start off with collecting the requirement. So once we collect the requirement, then we analyze the requirement on how it is going to be used by our end users. And then we start coding this data. So typically, since this is to do with data, we always use SQL language or Python or R language to do these kind of stuffs. And then once the data is done, we create reports through visualizations like Tableau and all those tools. These tools are really easy and user friendly, so that's the power using this. And finally, we do a quick validation, and then we roll off this to the users. Common skills needed for a data professional. There are 3 key skills needed for a data professional. The first skill is a data analyst. Data analysts, the basic role, what they do is they collect the data, transform the data, and publish the data and create insights out of this data. And data engineer typically gets the data from various sources, because we need to get some from fab, we need to get some data from assembly. Basically, their job is to pull data together and put it into a common platform. And data scientist is a very powerful role where we create predictive modeling to see how much is going to be our forecasted revenue, or how much is going to be our forecasted volume based on predictive modelings that we build. The common skills that you need for all these things are basic business knowledge and some bit of mathematics. And We also need some bit of programming language. This programming language, as I had mentioned, is really easy. Some common things are SQL, Python, and all these things, which I believe you guys are already doing it from the school level. And finally, to conclude, the common skills that you needed for both design and manufacturing includes logical reasoning. You have to be detail oriented, and the basic education of science, technology, engineering, mathematics is very, very vital. So with this, with our experience sharing on how our day-to-day life as an engineer, as well as our journey all the way from our secondary school, we believe that it enlightened you and will allow you to carry on your passion to do more on semiconductor industry as well as on engineering. Thank you.
Thank you, Arun and Hari. So we do have some questions right here. And also, before we head on to the questions, for the students who just came in to join us, you may like to download or go to slido.com. That's where you can post questions for our speakers. That's where we are. We also have a QR code for you to scan to head on to Slido. All right, questions for the both gentlemen. What is the work environment like at Silicon Labs?
We have a pretty good work-life balance. At some times, to be very honest, it might be a little bit hectic, but at these times, we have a very friendly colleagues and all these people. So typically what we do is, if we are so stressed up, we have our huge pantry, we just go and burn our stress by playing some kind of games and all these things. But typically, the work environment is pretty healthy, and a good thing is we have a bit culture of young people as well as old people. So if you have any questions, people are always easy to approach, and they always help us in clarifying all the questions that they have.
Thank you so much for sharing. Indeed, having a good environment is very important and attractive. Okay, so we are also curious, are we able to work from home as with your roles?
Yeah, so it again depends, because within semiconductor industry, we have various scopes. Like, we have sales, we have engineering, we have manufacturing and all these things. So I think my position and Hari's position, we typically can work from home, but there are some positions like engineering, because you need to really work with the hardware, and the hardware is currently in our office. So in those cases, you might need to come to office to do your work. It really depends upon the roles.